Welcome to Study Loop.
In this problem, we're asked to make a rough graph of a convex lens with 20 centimeter focal length and to describe where you have real images and where you have virtual images. For that, we're going to have to derive an equation first. So for this, I'm going to start with the thin lens equation, and I'm going to use this to solve for SI. So I have 1 over SI equals 1 over F minus 1 over SO. I'm going to go ahead and substitute in my focal length. And for simplicity's sake, I'm going to go ahead and simplify SO for just S because we're going to have a lot of variables kind of floating around. And I'm going to solve for SI. For that, we do need to inverse this equation. But when you inverse one side, you have to inverse the entire other side. So this becomes 1 over 20 minus 1 over S. And then we can find a common denominator. We're going to have a lot of little algebraic steps here. So this becomes S and S, and this becomes 20 and 20. And then you have this common denominator down here at the bottom. So we have S minus 20 over 20S. And then when you have a fraction in a fraction, I can go ahead and inverse this and becomes 20S over S minus 20. Okay, and that is our SI, but the problem was asking us to solve for an equation for magnification. So our magnification is negative SI over SO. So again, this is SI. So I'm going to go ahead and plug this in. So negative 20S over S minus 20, all divided by SO, which I've simplified to S. Okay, a fraction in a fraction multiplied by the reciprocal. These s's cancel out, and I'm left with a magnification of negative 20 over S minus 20, or SO if we want to put that little O back. Now, this equation is a 1 over X equation, which means if I were to plot magnification versus distance, I would get an equation that looks like this. Now, where you have a real image, and this is actually going to be our focal, and at our focal, we don't have an image, which is why you can see that those lines don't actually cross at that point. But when you have a negative magnification, you're going to have a real image. And where you have a positive magnification, you will have a virtual image. And remember, virtual images cannot be projected onto a screen, but real images can.